In one of our last videos we talked about the battery setup that will go into the new trailer. We have the electrical parts, and now we want to know how long the batteries will actually last. Did you ever think about going all electric? Well, we may have an answer for you after you saw our actual power consumption. In this video, we talk about the following 5 topics. First, we start with a 2-minute overview of watts, amps, volts, gauge and resistance. Second, we look at the battery and the inverter. We noticed some major limitations buried in the specifications. The power consumption is third with the appliances and the equipment. If you love coffee, you will like this part. Fourth, breakfast, lunch and dinner, and watch the batteries drain. And we show you how to slow down the process. And finally, we'll talk about what we learned and how we started a small electrical fire. Welcome to our escapades. Ursula is the navigator, my name is Dieter and I'm the wheelman. Let's start with a 2-minute refresher on watts, amps and volts. They are units to measure electricity. The picture in the background is the tunnel from the Niagara Parks power station. Green hydropower built over 100 years ago. Anyway, watts measure power, amps measures current, and volts measure voltage. The relationship between them is expressed as watts equals amps times volts. Therefore, a 700 watt 120 volt heater uses 5.8 amps. The math is watts divided by volts equals amps. As we know, electricity travels through wires. The size of the wire affects both voltage drop and heat generation. Thick wires can carry more current with less resistance, resulting in lower voltage drop and reduced heat buildup. Therefore, thinner wires have higher resistance, which can lead to greater voltage drop and increased heat. There is a real risk of overheating and potential fire hazard when the wires are too thin. To demonstrate my point, the toaster works on this principle. To get the correct wire size, which is measured in gauge, search for 12-volt wire calculator on the internet. You need the length of the cable and the amps and volts to get the cable gauge. The wire gauge for a 1 meter cable connection from the battery to the bus bar returned an 8 gauge or better cable. I bought a 2 gauge car jumper cable and cut that to the required length. For the inverter, refer to the manufacturer's cable specification when connecting to the battery. Second topic, batteries, inverter and appliances. I won't talk about the brand or model, but I will go into the limitation when using a battery and inverter combo. I built a test control box to connect the 2 batteries in parallel with the inverter. Each battery has its own on-off switch and a fuse before they terminate on a copper plate busbar. I had to create short jumper cables where the 2 gauge flex wire was not optimal. I needed a simpler version and took the ground wire from a standard 120 volt household wire. I twisted 4 of them together, and yes, there is a calculation to find the exact number of 12 gauge solid copper wires that will make up an 8 gauge jumper cable. 4 12 gauge solid copper wires result in 6 effective gauge. 6 gauge with 100 amps on 12 volts is good for over 6 feet. I have 2 inches. The fat cable in the center goes directly to the inverter. I took a shortcut when it comes to the bus bar for the negative wires. A stainless steel bolt locked them all together. However, I did some reading to find the best metals when building a busbar. Copper and aluminum are the top choices, while brass and stainless steel are further down the list. So here we are with two fundamental problems in my setup. First, the stainless steel bus bar is a poor conductor and will add resistance to the connection. Second, the 2-gauge battery cables are of different length. One battery has a 20-inch wire length, the other has a 12-inch wire length. That applies to both positive and negative. Remember, cables introduce resistance. The longer the cable, the more resistance. I don't have a formula to show, but these are the actual readings during inverter use. All cables from the battery to the bus bar must be of the same length. A longer cable will add more resistance and the batteries won't charge or discharge equally. We bought two CAN-BAT lithium iron phosphate batteries, 100 amp each, and a 3000 watt rich solar inverter. Why a 3000 watt inverter, you may ask? Well, it was in stock and only $30 more than the 2000 watt. A word of caution. A bigger inverter must be matched with the correct batteries. Let me demonstrate. I plugged in a heat gun with a 1500 watt rating. On setting 1, it consumes 650 watt, and setting 2, it consumes close to 1400 watt. I have two batteries in parallel that share the load. Looking at battery 1, the draw is 60 amps and battery 2 is 61 amps. The big question now, can I run the heat gun with my inverter battery combo? To get the answer, I had to read the battery specifications. Max continuous discharge is 100 amp. My setup with two batteries shared the load with 60 and 61 amps. To run the heat gun with only one battery is not possible. The two batteries share a combined 120 amps draw, and so the answer is yes. Remember what I said about wire size. Translating the 100 amp draw from one 12 volt battery calls for a thick cable. The 2-gauge cable to the inverter can handle 300 amps up to 1 meter in length. All my wire calculations are based on a max continuous load of 80%. And always remember, it is the combined draw of all equipment. 1400 watt from the heat gun plus 800 watt from the kettle will exceed the max load and hopefully pop the fuse instead of starting an electrical fire. And lastly, the inverter uses power when idle. Check the idle power consumption from the manufacturer, or better, check the battery load. Always power off the inverter when not in use. This reading is from the idle inverter on only one battery. The 0.6 amps draw will run one 100 amp battery down in about 6 days or less. Now that we built a 2-battery 200 amp battery combo, the focus in Chapter 3 is on appliances and equipment. On top of the list is the 120 volt Curadori induction single plate cooktop. And of course, the Nespresso Virtuo Pop coffee maker that runs on 120 volt as well. The two other appliances we tested were a toaster and two kettles. Beside these appliances, we charged our equipment. Ursula uses the Samsung Galaxy S23 Ultra and the Galaxy Watch. I use the Asus Zenfone 10. I use a Lenovo X1 Extreme laptop with the Intel Core i7 CPU. To capture the aerial views, we fly the DJI Air 3 drone that comes with a 3-battery charging station. I tested the oil-filled radiator at home to get some more numbers. The 12 volt power consumption was recorded with the CAN-BAT app on my phone. The numbers show the percentage of the available charge. A more accurate 120 volt reading was taken with the read power meter R5090. And the numbers from the battery usage are: we brewed 22 coffees from the Nespresso Virtuo Pop and used 42 amps. We warmed up 1 can of stew for about 12 minutes on the Curadori and used 14 amps. We got 1 liter of water to the boiling point using 12 amps. We made 4 toasts on a double slice toaster and used 11 amps. We charged the phone 7 times and used 24 amps. We did 1 hour laptop video editing and used 6 amps. Then we loaded the drone batteries from 50% to 100% and used 10 amps. We left the batteries idle for 1 week and they lost 4%. Now the burning question is, how many coffees can we brew? Well, our answer is, you will run out of coffee mugs before you run out of battery power. The numbers up to this point were taken during our trip to Tofino. The tests that follow now were done at home and required a controlled environment. I have 2 different methods to measure the power consumption. The first method is with the CanBat app on the phone. Select the battery, we have 2 of them. The first screen shows the available power in percentage. The second screen shows the current draw and temperature. The second is with the read R5090 on the 120 volt circuit. The display shows volt, watt and amps. The top line shows the current real-time values. The bottom line shows the accumulated values since last reset. That records the accumulated draw for equipment that has non-linear power consumption. I tested the oil-filled radiator at maximum heat and recorded the consumption on the batteries every 5 minutes. The label shows 700 watt, 120 volt. The read R5090 shows 660 watt. The battery drained 10% each, that is equal to 20 amps over 20 minutes. The second test was with the iSco Go 20 connected directly to the 12 volt batteries. For the first round, the iSco was set up as a fridge. I added 6 cans, 1 bottle of blue stuff, 3 freezer packs to simulate food, 1 topper with water, 1 Landjäger and a Gruyere cheese. Most of the goods were at room temperature. The fridge was set to 5 Celsius. The inside temperature was down from 18 to 5 Celsius within a few minutes. I opened the fridge 3 times to rearrange the goods. After 24 hours, the fridge used 12 amps on 12 volt. I repeated this test with a fridge freezer setup. I put 3 freezer packs in the freezer compartment, then loaded the fridge with 6 cans, 1 bottle of the blue water, 1 topper with water, 1 Landjäger and the Gruyere cheese. Most of the goods were at room temperature. The fridge was set to 5 Celsius, the freezer to -12 Celsius. I added 1 ice cube to test if it stays frozen. After 24 hours, the fridge-freezer combo used 45 amps. My last test was with the laptop. I measured the power consumption with the read R5090 while editing these videos. After 30 hours and 20 minutes, the total showed 1.498 kilowatt hours. That translates to an average of 50 watts per hour on 120 volt. Now, this is a value I can use to estimate my power needs. A typical day for us starts with charging the phones and the watch, followed by a cup of coffee, of course. Most of the time we have toast with honey and jam for us and our guests. Season permitting, we pick fresh fruits and mix with a cereal. To join a big breakfast, we go to a restaurant. After all, we travel to find new places. Now it's lunchtime. We prepare sandwiches when we head out to conquer new places, and when we stop along the way. Time permitting, we try the local cuisine. Usually we prepare at least one meal, or we take it easy with a can of lentils and mini sausages. Dinner is similar to lunch. We may have a campfire going, so the meal will be cooked on the fire. We usually have an electrical hookup. If we don't, the propane stove is the way to go, and we even use them at the same time. Our camping habits are, well, diverse. Starting with winter camping in a tent, taking a trip and sleeping in the jeep, or the jeep and the tent. Overnight stay with the trailer along the road, but most of the time we have a base camp where we stay more than one night to explore the area. We also opted for hotel rooms and watched the jeep and trailer through the window. We bought the ProLite Mini over 10 years ago and we are ready for more comfort. 2 weeks after the Tofino trip, we went to the RV show here in Toronto. There we met the good people from Outdoor Travel in Beamsville. We found our perfect solution: more comfort and keep the Jeep. Now we come to the last chapter. What did we learn? First, electric or off-grid camping has a good ring to it. It works for weekend trips, but a full week would require solar panels. However, we live and travel in Canada. An average solar panel efficiency under normal weather conditions in Canada is 50%. Add clouds and rain, that drops to 15%. Search for solar panel efficiency in Canada to find more details. Second, correct cable sizes and connections are crucial. We had a small fire when the negative cables came loose. Sparks and heat generation started a smoldering fire that was extinguished by turning off the power. The excitement was short-lived. The smell of molten plastic and wood lingered on for days. Third, the obvious biggest drain comes from heat generating appliances that run for several minutes. Toaster and kettles are bad. We didn't test rice cookers or bread makers, but they likely drain the battery fast as well. However, our Nespresso coffee maker runs for a very short time and therefore has minimal impact. Number 4. The silent killers are laptop computers, phones and watches. Same goes for drones and gimbals. We usually charge them in the Jeep when we are driving. And tip number 5. Get a power meter like the Reed R5090 to find the exact power usage. That helps you calculate the battery power needs ahead of time. Number 6. Our solar panel calculation is as follows. Breakfast, lunch and dinner drains the battery 36 amps based on our numbers. Add 12 amps from the ice cold fridge and we now use 48 amps per day. We have about 8 hours of sun per day in the summer month here in Canada. We need to charge 6 amps every hour to top up the battery. So, 6 amps times 12 volts is 72 watts, and this is the actual efficiency of a 100 watt solar panel. Search for actual efficiency of 100 watt solar panel. Canada has an average of 50% efficiency due to the high latitude and the flat mounting on the roof. So we need 200 watt solar panels. To charge the battery during less optimal weather, we had to double the solar panel to 400 watt. And now we have a chance to make it most days. Number 7. A clarification on the twisted copper wires. A 12 gauge house wire usually has a ground wire one size smaller. instead of 12 gauge, it is likely 14. The math for the short jumper cables still works. Number 8. So let's use battery power on a weekend trip without charging, no solar and no electrical connection. Leaving Friday evening, get a hot beverage like coffee Baileys and spend the night in the wild. Then a full Saturday with breakfast, lunch and dinner, and spend the second night in the wild as well. Breakfast and lunch, pack up and drive home. That adds up to 2 days at 48 amps per day. A 100 amp battery will just barely make it. To be on the safe side, 200 amps is the minimum and would include a long weekend trip. And last, a solar generator does not improve the odds. The same electrical laws apply. Do your research, they are not all the same. We had some unexpected experiences when we tested 2 of them. Read reviews from sources that do these tests exclusively and learn the technical lingo. Keep in mind, most product reviews look at the functionality and technical specifications. Not all of them will run down the battery to 5% and make sure they still perform as advertised. That's it. We don't have the solar system activated yet. That's why we crunch these numbers here. This video here is about usage, not equipment performance. Our 550 watt solar panels should keep up with our coffee consumption. As I hinted in chapter 4, we bought an RV. Not much will change. We will keep on exploring Canada. Our RV will be the base camp. The chip continues to get us to new places, but more about the monster in upcoming videos. Yes, the RV got a name. Thank you for watching, and we'll see you out there.